Hi and welcome to Rudy's Electronics Labs. Last week my son walked in and he had a brand new signal generator with him that he bought. And it is the new Siglent SDG1000X Plus series of signal generators. Now that's part of a rather popular series of signal generators. Actually I got its predecessor right over here, and I also have the a bit more expensive 2000 model over here. And I thought it might be kind of interesting to compare these devices for you. And it's going to be a bit of a complex video, I would say. The thing is that in the end, all of these three devices have their own weaknesses, but also their own strengths. And actually each of them can do some things that the other ones can't do. So it's kind of interesting which signal generator would fit your purposes best, and is it worth to buy this new signal generator, or actually to upgrade from one of these models to the newer series. So in this video we're going to look into it. We're going to do we're going to look at the new features. We're actually going to do some measurement and testing on them as well. But I'll start just trying to position this new device in the larger offer of signal generators. And I will also try to look a bit at the overall features that all the models share with each other. Now, so let's first go and see where the new model actually really belongs, and is part of what Siglent calls the SDG1000 series. And actually this is the third incarnation of this series. We had the original 1000 series from 2012, so that's 14 years old by now. That is discontinued, although later they made the 800 series, which seemed to be pretty much similar to what was earlier in the 1000 series. Then I think a very successful model, and I'll be using one with actually a lot of satisfaction over the last couple of years, was the 1000X series, and that had a number of serious upgrades compared to the original one. For one, both output channels became identical, and that was not the case on this predecessor. One of them was pretty much limited in what it could do. The number of built-in arbitrary waveforms went up. There is a really new design, a new display, and etc. An addition of LAN, etc. That's a significant thing here. And then just at the end of last year, it got updated by the X Plus series. And in this video, of course, we're going to look at what has changed, except the fact that, of course, we got a black unit right over here. Now, we don't only have the 1000 series by Siglent. Actually, Siglent makes quite a bit of signal generator, and looking into it, I think I found at least 37 different signal generator models, either being baseband or RF by Siglent. You see a bit of an overview here. Only a couple are discontinued, but most of them are now still actively on the market. The way they're differentiated, of course, is in terms of functionality and performance. We got some models, for example, that enter into the IQ domain, although in most cases then we still even need additional software to do it. We got a couple of RF generators that have, RF modulators built in them. And the devices that we're looking at, I think they're kind of in the sweet spot, because they are very affordable, I think, especially if you look at what they are doing and what they're capable of. And I find them, a really nice kind of sweet spot in the market for functionality and quality. Later in this video, we're going to go all into the nuanced differences between these devices, but in the end, they have way more in common than they differ from each other. The user interface is pretty much the same. The overall functionality is pretty much the same. So let me just quickly go through there, and this is not going to be a full review of this, but just an overview of shared commonalities between all the models here, the 1000, 2000, I think you could say all the SDG series, basically. So we know what we're kind of talking about. And two-channel waveform generators got, the regular type of waveforms, sine, square, pulse, etc. Quite a lot of parameters can be set on each of these things. They allow for modulation of the waveforms, and so there's a whole lot of different type of modulation: amplitude modulation, phase modulation, frequency modulation, and a number of other forms. They're also rather flexible because you can modulate with an external source connecting a BSC connector, but also a number of internal ones, including from the other channel in a number of cases. We got bursts of sweep, quite well done. And in one of my earlier videos, I also talked about that actually the sweep function on the SDG is actually better than the one that I have in my professional Rode and Schwartz SMI SMIC generator, which has some issues if you do like a sweep over a larger type of bandwidth. They got a harmonics generator, so we can make sine waves, but we can also add harmonics to them, even, uneven type of harmonics. Originally all the way until 10th harmonic on the old devices. The new device can do 16 harmonics, but by firmware change in the last year, actually all of them now can do up to the 16th harmonic. Of course, it's an arbitrary waveform generator. It got quite a lot of waveforms built in, and I think it's a quite nice kind of selection, even though everybody will have its own picks on it. We have waveform creation on your Windows computer with an application called EV-Wave-X, and that works well, but I don't think in every respect it is a easy application. When you install it, actually it wants you to install the full National Instrument Visa suite, and that is not only like an enormously large install, but there's all types of consequences on your computer and the DLL, and it also requires you to do a number of things in the startup phase of your computer, something that some people really, for good reasons, don't want to do. And I don't see any reason why we have to go all into this NI suite, because a lot of people, at least me, I just want to use EasyWave-X to create a waveform file, put it on a USB thumb drive and put it in a device. I don't need it, to communicate directly to the device. But there seems to be no way of installing this software without going through this whole type of thing. Now the good thing, once you did it already for one time, or you download it from somebody else, you can basically take a template or make a template files, just comma separated values, and whatever, use your favorite software applications to create value for your arbitrary files, and that works quite fine, even though I'm running into some issues that I might get into later in this video. What else do we have? We have some facilities between the two channels on the device. We got channel copying, channel coupling, channel tracking. We can control for phase deviation between channels. So that's all pretty well thought out, all on all the three devices. We got more here in terms of the outputs. We got two identical output channels on any of these. We got flexible channel combining, so you can be adding up the outcome of the channels. We got quite a large voltage swing of 22 volts peak, so from -20 to 20 volts, and that is over a significant part of the bandwidth, although the full swing depends a little bit if you go into really higher frequencies. We got phase lock on both channels. Sometimes overlooked feature, all of them have a frequency counter built in it, and it's pretty well equipped. You just connect the input with the BNC. You can calculate or measure things like frequency, duty cycle, whatever. It has quite extensive statistics. You can choose for DC coupling and AC coupling. You can adjust the trigger level. You can have high frequency rejection. I'm not sure anymore that's on all of the models. I'm coming back with a note on that later on. But it's a quite well equipped frequency counter. And especially if you connect a external, very reliable reference clock source to it, like a GPS disciplined oscillator, then you actually got a super accurate frequency counter here for a very reasonable budget. The user interface, pretty much the same between the devices, a little bit larger than 4-inch displays with enough pixels, I think, to make it look well. I know there's been some internet discussion that say like waveform generators should have like vertical designs and lots of pixels or whatever, but I'm quite fine with the interface as it has it here in terms of how it's organized. Some things I'll actually go a little bit more into detail, but you will see my more specific comments on that. Oh, hello, you're coming to join us. We got internal memory, we got memory from a USB drive that can be connected from the front of the device. We can use it to store and recall the setting of the device. You can quickly go back into a known configuration setting. We can use it to store and to load again arbitrary waveforms. They can be in a comma separated format, but there's also a binary kind of dedicated format by Siglent itself, and another type of file that I didn't get into. It's not documented very well, but a DAT data file. We can store screenshots on it. Screenshots is something that now after a recent firm grade all these units can do, although there's a bit more to say about it I'll get to in a moment. But what all the devices share at least is that the screenshots basically only go to the internal memory, and you can copy it to the drive, but it's quite a lot of keys that you have to press to do it, and if you have to do it for a whole bunch of key shots, I really would have preferred if a screenshot should go directly to the USB drive. There have been regular firmware, or you can use at least I should say the memory, the USB drive for firmware updates, and Siglent has been issuing firmwares at a rather regular rate for their devices. We got a basic file manager, basically to move your files around between internal memory and the USB drive. We got quite a couple of interfaces. Standard is USB, and we can also control the instrument over it. Standard for all the devices except the very old 800 is a LAN connection, and optionally you can have a GPIB interface that goes via USB to GPIB external convert. I don't have that one, haven't tested it yet. You got like a good design with self-test on the internals of the device. The user interface. A couple of more things that all the units share is that there is the possibility to connect to an external reference, and there's a possibility to take out the internal reference signal of the unit. The configuration by which they do it is different, and I'll get into details on that. We got the I/O for the frequency counter I already mentioned. We got a universal auxiliary port, can both be an input and an output, and in terms of input you can use it for things like external modulation or external triggering to start things happening, for example, or you can configure it as an output, for example, for basically the waveform sync out, but that is disabled in certain situations, and it's disabled for sweep, for the use of burst, and when it's running at higher than 10 megahertz, and disabled in a kind of very particular cases that are relevant later when I'm going to look at the 100X Plus unit. The auxiliary output can also be used to trigger out in cases of sweep, and as general observations we have a high build quality. They're very, very sturdy and well-made devices. I like the way also they got the bumpers and the handle. You can take that off and mount them more tightly into your lab. The frequent firmware updates to the device. Generally speaking, I think the user interface is good, but I'm gonna talk about some exceptions. And generally speaking, I think the firmware is stable, but also there I'm going to talk about a number of exceptions in my video today. Yeah, so going to compare these three units today, I decided to download the latest version of the firmware of all of them. I think that will be the most appropriate type of comparison here. And you see here from the top or to the bottom what is the most recent software that I installed on the machines, and that is as of January 2025. Now there's one particular thing that I should mention when I went to this new firmware updates, because the moment that I started the new machine of my son here, I already noticed that something had changed, and in particular the font type seemed to have become more difficult to read in terms of the machine's main settings. And after I did a firmware update on my existing machines, the 1000X and the 2000X, they had exactly the same issue as well. And in the picture that I'm showing you now, you see the old user interface and the new interface, so with the firmware version that were released last year. And I think it's really a step back. I don't know, the same thing happened as well to the Siglent SDG1X Plus oscilloscope. I talked about that in another video. They changed to another font which is harder to read than the original one, especially at some distance or if you use glasses or whatever. Really, I would really appreciate if Siglent just stayed to their original user interface. They were simply better, I think. They did add a couple of small features here, and you see they create a bit more clarity on the output impedance, and as most of you know, these devices always have a 50 ohm output impedance, but they have a possibility to switch, which can basically tell you whether you're actually seeing the voltages as they will be on an open load, or whether you see the voltages as they would appear if you would load it by 50 ohms. But the output is by definition 50 ohms. Nothing physically changes, and I think that is reflected a little bit by what you see noted here in the new screen. But altogether, yeah, that's a step back, and I'm even thinking, you know, to load all the firmware here. Now we're going to focus now on the new unit, the 1000X Plus unit, and the most apparent features, and also the one that Siglent is advertising basically, is, well, very visible, a number of physical and user interface changes. We got better specifications, at least compared to the 1000X predecessor. So we go from 14 bits to 16 bits. We go to a much higher sample frequency, and we go to a way larger memory from 16K to 8 megapoints memory. Very significant. Most visible are the new type of what I would call waveforms. We got multipulse, we got pseudo-random bit sequences, and we got sequence. And especially the pseudo-random bit sequences, so things like PN9, etc. You've already seen in previous video, that's a bit of a favorite topic for me. So I'll be looking into and how they are implemented. I can already tell you there's some nice things about these new waveform things, but they're definitely also suffering from a number of implementation choices that I don't exactly see why they were made, but make it actually less useful in this device as I wish if there were when I was first seeing the data sheet of this device. Interestingly, we also got differential pair output, so the two channels are used to create differential channels, and you can set them at logic levels like TTL and lower levels. That's something new compared to the previous unit. But also here they made some implementation choices that I really would have liked seen separately. We got physically an additional connector on the back. We got a separate port for sync in, clock in, I would say, and clock out. And that can be a useful feature, especially combined with the multi-device sync mode that is part of this device and not of most other devices of Siglent. I'll go deeper into that, probably do a separate video on that. We got a web server now. We got LXI support for those that do lab automation, and we got a number of features that are important from the 2000X models into the 1000X series. Makes me wonder if there's going to be a 2000X Plus model, and yeah, what they would do there. Maybe we would get something like a full IQ. I'm not sure we will. That's just a speculation. Now, focusing first on the outside of the unit is black. Black seems to be the new beige. I leave it to yourself whether that is your preference or not. I kind of got views in it. One thing that we can definitely see the moment that we start to use the device is that the screen is way brighter, really way brighter. That I don't know if you really see it well on the camera screen here, but certainly a screen that is not only brighter but also in terms of viewing angles is better. In terms of color, gray is a bit of brownish, but maybe I'm being a bit too critical here. We got the same button settings on the UI interface as we had it before. However, I should note that a number of these buttons have lights, LEDs behind them. Actually, it's exactly the same configurations in LEDs than before, but they're very hard to see now in this new version, where in the old device you could easily see also in daylight whether your outputs were activated or which menu you were in. In a new one, you really have to look very carefully because the lights are very hard to see. And one thing, okay, let's also say some minor thing, but I wanted to mention, they changed the channel layout color scheme. So the printed colors on the outside of the device now are different. They changed from, what is it, blue to green or green to blue. I don't have it on top of my head. But it's a bit weird because then on the device you can also go to another setting to reflect it, but it's not activated by default. And actually this new color scheme that does correspond with it, it looks rather pale and not very nice to the eye. Yeah, I wish they would have sticked with the other one. But we're still looking at the outside and the cosmetics here, and now we're really going to go dig deeper in the functionalities of the device. a quick check on how quickly the units start up. So I connected all the 3 power supplies to the same switch outlet, and I'm going to try to start up all the units at once. 1, 2, 3. There we go, they're all powered. And as you can see, we got a slightly more colorful logo now on the 1000X Plus device. And there's normally some clicking of relays going on. We're into 70 seconds now. And we got 21 seconds and they're turning on. And everything is turning on except the 1000X Plus. It's going to take more time. And we're on to 30 seconds or whatever. And there we are running into, well, we're already over 40 seconds. We're running towards a minute or so, it seems. So this is really a big thing. It's much slower in starting up. Okay, next I want to talk a little bit about making a screen print from the device, and that also allows me to talk a little bit about USB sticks and the file manager. So first of all, we'll be inserting a USB stick, and with most of the sticks I have at home, I basically get the message USB drive removed. And with most of the USB drives at home, if I insert them, I'm getting the message USB drive removed. And that basically means that it doesn't recognize the drive. Well, it seems only to work with pretty old drives. I have the feeling that all USB 3 drives or recent drives I have at home don't work with the generator. So actually I'll be inserting a very old drive I got somewhere lying around. And then we get USB drive connected. So we seem to be okay now. Now, if we want to make a screen print, actually it is a undocumented feature. It's not anywhere in the user manual or in the firmware upgrades. There is already one firmware upgrade for the device. But actually, if you press the store recall button for a couple of times, you get screen BMP is saved to local. Now, that is a thing that you cannot choose to have it saved to the USB drive. So you'll have to be moving it basically from the internal drive to the stick, which is possible because there is a basic file manager there, but it is actually not that easy. And if you want to do it in the right way, also moving up what you left behind on the drive, it's actually going to take you some 16 different actions to do so. So I'll quickly go through that. I'll not bore you with the whole procedure. Okay, so there we got it. So if you have to do this for a lot of files in a row, this is a bit tedious or so. So I like the screenshot feature because it's really good for documenting type of purposes. But I really wish you could save directly to the drive. A couple of more particularities that we got here is that you have to be a bit careful with file names. Now we were just working with screen prints, but if you have a file name that you got from a computer, for example, a WAV file you created with, for example, a space in it, it won't actually be able to copy it. It can load it and work with it, but not copy it for some reason. There are also some issues with the screen prints in terms of colors. When you are in the UI style normal, all the colors get messed up. I'll also get back to that later. And the date of the screen print is always going to be 9080 because at midnight, because the device doesn't know time and date. And if you do this for documenting, then this is a little bit difficult or so. As a final thing, screen prints are also available in the older models. They were added as a firmware update in 2024. It works well on the SDG1000X. On the 1000X, you actually get an empty error message. So I thought it was not working. But in the end, I found out it actually does save the error, the screen print, but just leaves you with an empty error message. So that's something in the firmware there to be updated, I would say. further going to explore some new functions on the Siglent device. So this is the regular type of menu here with the waveforms, the sine wave, and then the new functions that we didn't have in the previous device are here: multipulse, pseudo random bit sequence, and something called sequence. So let's start with the multipulse over here. I activated and already see on my scope, which is set on channel 1 and channel 2 of the generator, and the auxiliary output here, but the scope only had one trigger and then has stopped basically here. I'm going to clear the sweep of the scope. So the first thing we'll need to do here after it's turned on basically is to choose a trigger setting, because by default it is on manual trigger. So if I press the button, yeah, so already see here a white and a small pulse coming, and indeed instead I'll be changing here basically to a timer, and I'll set the timer value to 0.4 seconds, for example. And then we have a continuous trigger going on here. Funny, by the menu, for example, sometimes there's no capitalization. Some of the software seems to be written a bit in a rush, to be very honest with me. But anyway, focusing back here on the trigger unit, we can have like pulses going on. So you see here a pulse train coming in. And what is this really about? What would you use it for? One of the things is to look at dynamic behavior of devices. Could be switched power supplies, could be any type of light that might be dealing with DC values or pulse things, fast reactions, etc. And this is where it is meant for. It's set to a fixed sample rate, it's seen from here, and we can basically have a number of influences on the pulses and the width of the pulses, etc. So we will play around a little bit with the positive width, for example, and then we will directly see here the effect here on the various pulses. So this basically seems to be doing what it's supposed to do, and also a nice feature, if we go to the utility menu and we go to syncing and we activate syncing on 1, we do get a pulse on the rear exit BNC about syncing to it. I noted that the sync comes all the way at the end of the pulse train, not in the beginning. That might have been a conscious decision from Siglent's side, but this is something to be aware of. Of course, you might have expected basically that the sync pulse will be right in the beginning of in the pulse train. Okay, so much for the multi-pulse functionality. Let's take a look at the sequence functionality. So if we go here and it starts again in the stop state, actually there is no signal here, but I just see the last time that my scope was triggered here. So what we basically see here is a possibility to build up a sequence of waveforms that are available as arbitrary type of waveforms. So we first have to create a combination, a sequence of these things. So there's sequence setting here and there's sequence edit. And in the sequence edit is all happening, and we see now we already got one waveform being present here. So let me add a couple of waveforms. I'm adding a segment, go to the segment settings, I choose a data source for it, and over there I can go to built-in waveforms. There's the stairs waveform, for example. I'm going to select that one, I'm returning, I'm going to add another segment, going again to the segment settings menu, to the data source. You have to do a couple of buttons to get there, and let me see if I can get like something else, like noise, for example, so I can really distinguish the three. So I got 3 elements now ready in my sequence. Again, a bit of this inconsistency of the user menu in capitalization and wordings. There are a number of things you can make: loops, you can do the go-to, there are a number of other things. I'm not going to get into great detail here, but I'm going back to the start menu, and I'm going to go to the running mode. And as I can already see here, already got a number of things coming in here in sequence. And as we directly see as well, we still got a sync, luckily enough, that's coming out of the auxiliary port. It was still activated of the last action. So if I actually will be setting up my sync of my scope to that port, I should be able to get it nicely in place. And there we go. We got the 3 waveforms that we just programmed into it, playing back in sequence, and that basically characterizes the the new sequence function that is offered by the 1000X Plus series. All right, let's go and take a look at the pseudo-random bit sequence. And that's one of the features that I think Siglent put quite central into the marketing of this new unit, and it's also one of my favorite topics, as you can see from my channel. So we're going to dig to it a little bit deeper, and we got a bit of a larger measurement setup here, because we got the Siglent itself, we got the oscilloscope, so we can just check the signals and also see the amplitude and possible other syncing signals that we're interested in. We got a bear tester right over here, been using it in my channel before on a variety of different videos. And I got also my own little bear tester right over here, my homebrew that I also have a number of episodes on. And I'm very curious how to, how it performs as a generator of pseudo-random bit sequences. And well, first of all, maybe as a reflection, what are these type of signals useful for? There are a number of different applications, I would say, but probably the most important ones are bit error rate testing, that's kind of the classic one, and another one is looking and investigating eye diagrams. Now, I saw some pictures of eye diagrams in the Siglent brochures, etc. I'm not sure that will be my preferred device for that, because if you want to do that, you want to do it at high frequency and really making use of rise and fall times that are exemplary, and I don't think we have that here. So for me, basically, the bear testing scenario, which is much more tolerant in terms of the signal that you make, that is kind of the most interesting type of application, I think, generally for this function in the machine. So let's just see the measurement setup and see if everything is working properly. I pre-configured everything a bit. Actually, I've been already working quite a bit on this, and I'll tell you in a moment why that is the case. So I'm first starting with my own little bear generator here, just to see if everything is configured properly. I got the data signal coming in. I'm taking a bear signal, and there we go. We basically see that the bear receiver has received the signal, has been able to sync on it, recognize the signal, and it's all coming in. And at the oscilloscope, we also see here basically what is going on. I just put it here to see that we got a clock frequency of 100 kilohertz here. We got a TTL type of signals, even a little bit weaker than TTL, or more or less TTL. We're fine on that. I just want to be able to check the absolute voltage levels here. Now, going to this device and already put it into PRBS mode. And the first thing we will notice here, there are a number of settings. We got bit rate, amplitude, and for the amplitude part, we basically can also go to logic levels like TTL, etc. If you press that, we cannot do cancel, so I'm not going to do that right now. I already set it myself to 5-volt amplitude, 2.5 offset, so that will be a TTL compatible signal. I checked it, and actually it's exactly the same if I put it on TTL. We got a rise and fall, and we got the code length. And in previous videos, I've always been working with code length 9, so we're also going to do this for the time being right over now. These are kind of the basic settings that we have here. We don't have a standard clock out signal. That is a bit of a limitation, because most of the scenarios we have, like testers like this one, you do need a clock signal. This is not going to work without clock signal. Unless you have a receiver that has a clock recovery circuit built into that. That's not the case, for example, for this Anritsu here. So what can we do? Well, we can use the second channel basically and let it run in sync and let that create a clock signal, and then seeing if everything is going to be all right. The second thing we typically want of a PM generator is a sync signal, so we can see when a whole new sequence is coming by. And normally the Siglent has a quite nice feature for that, because normally speaking on the Siglent, if you have any waveform playing, you can actually activate the auxiliary out mode, and that can be used as a sync signal for the whole waveform thingy. So let us go there, let us go to utility. It's in the sync menu here, and we channel 1 and we put the state on. DC, noise and PRBS can't output a sync signal. Whoa, that that is quite a thing. I mean, I completely understand you cannot have a sync signal for DC or for noise. It doesn't make any sense. But you cannot have it for PRBS. And that is kind of the most important one. I mean, you can have it for sine, you can have it for arbitrary, for anything else that it can do, but not for PRBS. And that's where I probably need it the most. So we have to go and live without sync signal. That's not so important for bare decoders or testers basically, but to investigate the whole signal and to be able to sync on the oscilloscope to see the start of the sequence, know where things start and end. I find that very useful. But anyway, we have to live with this, this limitation apparently. We kind of could use the second channel here to create such a sync signal by just telling it that it runs 511 times slower than the bare signal itself, because the bare length of a PN9 code is 511. But then we lose, of course, the sync, or we have to set up 2 signal generators at the same time, get them in sync and everything. It's a bit of a difficult thing, but anyway, now that is just an observation here. But let's see if it works. So let us move it basically here from the working configuration here, and we get the clock signal, which is on channel 2 here. So again, I'm getting a decent clock back, and we get the PN9 signal here from output 1. And what's happening? Now we see the PN9 signal coming in, we see the clock signal coming in, but it's not synchronizing my bare tester. And I actually spent like half a day of trying to get this to work. I tried every scenario I can think of. I've been working on the output levels. I've been working on 50 ohm termination as an input to this device, still securing that we got the right TTL levels observed. I've been trying the clock polarity and the data polarity. I've been trying phase delays of the clock signal compared to the bitrate signal and everything. I just can't find it. I also tried to do other bit lengths, so the 15 lengths and the 11 lengths, that this device can basically do them all. All of that does not work. I don't manage to get these codes to work. On top of it, I've also tried another bare tester, which is the Firebird that I recently did some episodes on. And the Firebirds also work with all other sources of bare signals, including my SMIQ and my homemade one, etc. Yeah, it just doesn't work. And I have no idea what is going on here. Is it creating a type of signal that is not fully compliant, mathematically speaking, having the properties that you need, that he can recognize it, because it will need to have some properties in terms that he recognizes where the 511th bit code starts and ends, and that he can see the repeating things. Hence, I also tried it for a couple of other codes, but none of them seem to work. I don't want to come too quickly to a conclusion, so I'm not going to conclude yet that there's something wrong, but I really will be happy if somebody can comment on it, how to get this working, because I'm using quite a lot of this type of stuff recently. I managed to get everything working together, but it didn't. Now, we could leave it at that, but we can also kind of take a next step here, because after all, this is an arbitrary waveform generator. So why don't we just try to create some of these waveforms ourselves and see if we can do a better job, or at least get something working that we earlier didn't get working. And I've been trying to do that. Now let me get a little bit closer. The nice thing about the device that we can have all kind of configurational settings in here. So I got the setting that I just had here, but I also got a setting right over here. And this is a code that I created myself. So I just took a PN9 code. That's actually the same code I've implemented in my homebrew generator. I created an arbitrary waveform out of that. If you just take the 511 points, that would not do, because then it's simply going to interpolate between these points, and you got a very weird waveform that I'm showing you right now on the screen. So what I did is that I filled up a 16K sequence so I stretched it out to 16K, so a lot of ones, a lot of zeros, according to the precise pattern here, and I will be sharing that code as well. I could have made it longer than 16 kilobyte, but 16 actually works on all my Siglent devices, also the 1000X series, and there's no reason right now to make it much longer than that. So I got all the configurational settings for the device itself, so it will, let me just do that right now. I'm going to recall it, file import complete. So what it has done here is basically it has loaded the wave sequence that I saved myself. It's got the right amplitude and offset settings here. It also created a second channel, and the second channel works at a different frequency. So the third channel is running at 100 Hertz. The second channel at 51 kilohertz. What is the reason? Because the whole 511-bit sequence is one single waveform here, and the clock has to be 511 times as fast, because this the arbitrary part is not the clock of the bits basically, but the clock of the whole sequence of bits coming by here. So putting these things basically together. So let's activate the clock signal coming out, and let's activate the pseudo-random signal. Yeah, and then it works. So basically, if I just create my own PN9 code, I get the Siglent to do exactly what I want it to do, but it doesn't do it with the built-in new functionality. Now there are two nice things about, I think, the way that I did it right now. The first thing is that this will work on any Siglent SDG generator. I think the code that I used here, and I will be sharing, actually work on any generators, also the one that I don't have myself. So you don't need actually the new model to do that. The second thing which is nice about that, let me show that to you. I can now, again, what I did earlier, go to utility, I go to sync, I choose channel 1 as a sync state, and I'm turning it on. Actually, it was already turned on in my thing. And as you might see here on the scope, everything started to trigger here, because actually my scope is now set to a third channel, and that third channel, let me make it much bigger, that third channel actually is the sync output here. So now I suddenly have my desired sync output thing. So not only does my own little code actually work on a PBRS tester, but I also got both a clock signal and a pattern sync signal coming out of this. Now I think this is as far as I can go with pseudo-random bit sequences on this device. I'm not getting it. I'm not getting it why the built-in new functionality is not recognized by my Anritsu, not recognized by my Firebird. I think I looked into all the settings that could possibly affect its behavior. Open to suggestions, just write them in the chat below this video. And if somebody comes really with a sensible point, I will investigate that again. But for the time being, I'm going to leave it as it is. I would not buy the Siglent for the PRBS function if you really want to use it for testing type of purposes. Yeah, unless it's really clear that it works. Another new functionality that I would like to point out is that we got logic levels and differential outputs on the device as part of the new PRBS waveform. So how does it work? Pretty straightforward. You go to logic levels and you can select any of these logic levels, so TTL, CMOS, but also a couple of lower level specs. And what it basically does is setting the amplitude and the offset in such a way that's compatible with that logic. So that's a nice little feature. On top of that, quite interesting, you have differential, and you can turn differential on, and you're going to have differential output here. So you're going to be having the opposite signal on your second channel. You also see that the second channel is turned off here. So I think these are kind of useful features. I like their inclusion, but I really have the feeling that I would not like to have them see them exclusively here as part of the PRBS function only. For me, it would make much more sense if this would have been part of the general output settings of the device, where we got wave combine, and then we could use these functions basically with any waveform, to have a differential output and to have logic output for all what I would call like digital signals, like square, for example, or pulses, etc. That would have made it, you know, much more more generally appealing, etc. Except for only having that in PRBS. I think it still could be basically still moved then in a new software update, making it really more valuable. One more novel functionality that we didn't find yet in previous SDG series is a web interface. Quickly going to take a look at that. We go utility and we go to the interface menu. That's already something we already know. The new thing we're already seeing here is the web passports, already revealing there's going to be a web server here. And by the way, also LXI, which I already mentioned, which is basically remote control for laboratory things. I'm not going to go into that one, but I'm going to do the web part. So the web setup basically has here the IP addresses. New is here the two lines on the bottom. The other lines were already there for regular type of control. So we got to look up this device from the IP address that was assigned. Automatic assignation, DHCP is activated here. So we got address assigned 192.168.174. I connected the cable here. So I'm going to go to a computer interface now, and we're going to look at that particular address now. And there we go. We got the device available here, some instrument information, and some of you might already recognize a little bit the looks of this, because this is pretty same, I believe, to the web interface we find on other devices like the SDS oscilloscope series. Basic device information, some information actually is not in the manual about the implementation of LXI, etc. There's going to be a bit on the lung configuration, same parameters as we had before. There is the possibility basically to query the devices with SCPI commands here. So if my memory, wait, star IDN, question mark, send that one. Yeah, I still remember at least one command here basically, and the answer to this query is going to tell me which device I have and the software version of the device. Great. Of course, what we're most interested in here is the part called instrument control, and we basically get here a basic overview of the device, and it works more or less as we would expect it. Now, this is pretty straightforward, I would say, in terms of how you would have normal controls. You would go to a parameters here. We can choose a parameter. We can enter values from the computer keyboard, etc. So that works all pretty fine. Now, what you probably want to pay a little bit attention to is basically how do you control these things that are not the buttons at the bottom of the screen, but elsewhere on the device, like turning a channel on and off, or going to in particular modes or so. And that is a little bit more of a challenge to find how things work. So in terms of turning channels on and off, for example, now we have to go here to this output part here, and then we have on and off, and we see that reflected above here, but here we cannot click. We have to click here basically down here. Suppose we want to change, for example, the waveform. Normally that's a specific button on the device, but we don't have that button here. Basically we can click here on the waveform, and then we get in the bottom basically to the settable part. So I think kind of for everything there is a bit of an equivalent. It's a little bit of looking around where it was. I might have appreciated to have just the buttons over here, as you sometimes see on instrument interfaces of devices. My Keysight oscilloscope has it, for example. But you have to find out a little bit your way around. But I think basically you can do all the functionalities using the interface that you're seeing right here. So so that's basically the web interface and the way it's implemented on the device. One other functionality worth exploring is the multi-device sync, and where can we use this for? Now, say that we want to have 3 different signals rather than 2 signals. For example, a 3-phase power supply, and all of them with a harmonic element in it, for example. This new function basically allows you to use multiple signal generators in tandem and make sure that they don't only sync in terms of the clock signal, but also when the waveform starts. So this is a functionality which you don't have in all Siglent devices, but you already had it in the more expensive 2000X series, in the even more expensive 6000X series, and now also in the 1000X Plus. To activate that activity, you basically go to Utility, First Page, and Multi-Device Sync. It's the same story here. Utility, First Page, and Multi-Device Sync. And you already see a bit of a picture, and it actually works by connecting up multiple units, not only by the sync signal, but also by the auxiliary wire. And that auxiliary wire is then used to send a signal, basically synchronizing the two devices. There's a bit of a hardware difference between the devices. The 2000 series has a combined clock in-out, so it can only be used with for maximum of 2 devices in a chain or be the last slave. The 6000X Plus, the expensive one, and the new one here have separate connectors for auxiliary, for sync 10 MHz in-out, so you can make a much longer chain. So basically what you can do is create a master and a slave. I'm going to activate the master here, so I see it on the screen. I'm going to activate the slave here, I see it on the screen, and then we can basically sync devices with this button. And we also have to do a time delay using an oscilloscope to adjust for any timing difference between the devices. I'm going to leave it at this here. I didn't fully get the timing delay right when I was testing this, and I'm probably going to make this a different video by itself. But in principle, this could be an interesting functionality if you really want to have a 3 or more channel type of setup, but don't want to spend a fortune on buying a device that supports more than 2 channels. Now, I promise you also that we will do a in-depth review looking at all the specs and performance parameters. I tried to put it all together, and in the next couple of sheets, basically, I'm going to show these specs, but I'm also going to kind of highlight where the particularly interesting changes are and the commonalities between the series. So first, looking at the basic specs. We basically see that, let me also mention, I gave you the spec for the top model out of the series. Typically speaking, the cheaper models with lower bandwidth have the same hardware and also the same performance, insofar as not related to the advertised frequency, which is nice. So we're looking at the top model specs here. One thing is notable that now with the new series we actually got 3 versions, 25, 30 and 60 MHz. Not a big difference between 25 and 30. I don't know if this is market segmentation, price segmentation. I think in the Netherlands the shops that I look at, they only sell the 30 and the 16 version of this unit. Sampling rate went way up, although I must note this goes with interpolation there. And we also see basically the sampling rate for true ARP and for DDS that are different than for the regular type of thing. The resolution went significantly up from the predecessor, from 14 bit to 16 bit. No question about it, that is desirable, that is better. Time-based accuracy with much tighter, now as good as the 2000 series. The true ARP feature, that used to be a distinguishing feature between the 1000 and the 2000 series, but actually it was added with a firmware update, so no differences there anymore. The waveform length, yeah, there is a huge difference. 16,000 points only on the 1000X series, and now we go to the 8 million points there, similar as the 2000 series. So in many senses, this device is actually almost a 2000 series in disguise. Looking a bit now at the stated performance specs when it comes to making different waveforms, and it's quite interesting. They all kind of differ a little bit. So the sine wave, we see here, square wave. And okay, now we get into something interesting. The cheapest model can go with a square wave all the way to 60 MHz, and the other models significantly lower, even though they're more expensive models. And there's a bit of a story there, I would say. And we'll get to that story in a moment if we look at some of the other specs as well. Got a new multipulse function, and there we got up to 30 pulses here, as you see in the specs. We got the art generator. Yeah, that's faster than it was on the predecessor models. Already told you that in terms of creating harmonics on the sine wave, actually after firmware updates all the devices are the same now. Showing you something of the pseudo-random bit sequences. That's a new functionality, and the waveform sequence. I already told you about the output voltage, a quite generous 20 volt peak. However, on the old model that was limited to 10 megahertz, and in the new model that is all the way up to 20 megahertz, we're still getting the 20 volts, and then it goes down to 10 volts. But I think that's typically still good. Then the rise times, and I know there's a whole discussion on the internet has been focusing on that element only. And interesting here, again, we see that the cheaper model series is doing much, I could say, quite much better than the other series here. And we don't see that in any of the other specs. Why is that really the case? The answer to that story really can be found in the documentation that we have of the devices, because the original 1000X series has a special separate circuitry that's making these square waves, and this separate circuitry has much better characteristics in terms of rise time and fall time, and much better than the regular type of engine that is used to create things. Since so much of the discussion on the internet about this new device is about the rise and fall time compared to the predecessor, I think I should also pay a little bit attention in this video. So a setup of 3 devices, an oscilloscope to measure rise and fall time, so the time it takes basically to get from 10% to 90% of the output signal. And I've connected a Leo Budnar pulsar here, and that is actually a very nice little device. It is a 10 megahertz square wave generator with a super sharp square wave, way better than actually the oscilloscope can measure. So that's a reference point, so I know when there's a limitation towards the scope measuring or where I'm really measuring my input signal here. And the additional clock output is connected here as the clock input to all these devices, so everything is running here in sync. So what is the result we are seeing? I got the devices here from top to bottom, 1, 2, 3, and the 4th channel is the Leo Budnar pulsar, and I also I see all of them making nice 10 megahertz square waves as an output, but I can already see that some square waves are steeper than other. And I set up my scope basically measurement function to show that, but in order to show it properly I should only get like 1 waveform or so into the picture to properly measure rise time. So let's look at the result. And so the Leo Budnar pulsar is about 2 nanoseconds or less. So that is where the limitation of my scope is. For the new SDG1000X Plus series I get a rise time of about 11 nanoseconds. For the more expensive SDG1X I get a 8.5 nanoseconds. I think we also saw that in the specs. It's a little bit faster. And for the cheaper SDG1000X series, the predecessor, I get an amazingly good rise time of 3.3 nanoseconds or so. So indeed that is what we saw in the specification. This got a spectacular good rise time all the way to 60 megahertz if you have that version, I believe. Now, it is important to point out, and I'm going to put back my scope into here, that this is not the case for all output here. If I basically go to a pulse output with a 50% width, which should deliver exactly the same signal, you see I'm getting a much worse rise time, about 60 milliseconds, nanoseconds instead of 3. So basically the general engine is really not as good as in the other devices in this respect, but the special circuitry that is only used basically here for square wave, that is really where the device shines, and it has such excellent type of output. Coming to the end of this comparison, all of them feature this frequency counter only on the 2000 series. We can also choose for a fast readout mode. Not any of the other models have that. But then interesting, there are a couple of new features added now to the Plus model. which is that we can do manual triggering. So if you want to start a startup process, etc. now to both channels. That was already something in the 2000. Using one channel as the modulation source for another one, that is now still limited to the 2000 series. But what we get completely new to the X Plus series is a amplitude sweep. And also some setting in ARP interpolation mode, although I haven't digged into that, but that is different from the previous devices. In terms of the physical side, in and output, we get separate in and outs for the clock. And that's kind of interesting. We want to make a longer chain of devices and use the next function, which is multi-device synchronization. There we can have multiple devices connected together. Now on the 2000X we had a touch screen. To be very honest with you, I'm never using it at all, so I don't really care about it. With the Plus series we get a web server, that is kind of nice. And we also got LXI support for people to do web automation, something that none of the previous models had here. Now, this has been a long video and longer than I had anticipated, because the question I wanted to answer, is it worth buying or upgrading to this signal generator, the answer to it is quite a bit more complex than I originally thought it was. So what I'm going to do to conclude this video is, first I'm going to tell something about what I think could be improved by it. I will call it a wish list. And secondly, I'm going to deal with the question, is it worth buying this unit or upgrading one of the previous units to this one? So let's start with the wish list. Well, first of all, I would appreciate if the differential pair output would be available for any mode, so part of the output combining menu, rather than only linked to the pseudo-random bit sequence mode. Relatedly to that, I would also appreciate if the logic level settings would be available generally all around the device, for any digital mode, I would say, that is like a square wave or a pulse, etc., rather than again only for pseudo-random bit sequences. And then about the pseudo-random bit sequences implementation, there I'm very puzzled. As I showed in this video, I'm not getting it to work, and I tried with several bare analyzers. I think I went into all the different things I could think of. All the other sources of this type of signals work perfectly fine, but I don't get this device to work at all. And actually I just get it to work when I create my own ARP sequence, but then you don't have to buy this, then you can do it with any of the others as well. Now, if this should work well, I'm still leaving the jury out, so I'm happy for comments on that. There are a couple of other things. Please, Siglent, activate the sync out. It's available on all the other waveforms, and on this waveform you need it more arguably than on the others. Also offer a clock out signal without having to sacrifice other channels or differential pair outputs. And a nice add-on will be to have more programmable patterns and or dual channel patterns, as we see them on some other devices that have this type of functionality. I kind of still miss a bit the special square wave function of the predecessor. And I put this in blue on the wish list because I think this is the one that will actually require hardware changes, so it's not that likely to happen. I think kind of all the other things that I'm mentioning might be possible within just a firmware upgrade if Siglent really wanted to. Continuing a bit with the wish list, I would really like to have a better USB thumb drive and file system compatibility. I see that many thumb drives are not working. It seems that any of the modern drives that I have here, USB 3, are not working. The file system has kind of strange type of behavior. File names with spaces can be loaded but not be copied, etc. It would be nice to take a bit of a good look at that. Another thing I would really like, that the new screenshot function, great is there, but please allow it to drive them, to save them directly on the thumb drive. You have to take 6 different steps, basically, buttons or turning wheels to actually do it, copy it from the internal memory there. Just like any device, just save them on the thumb drive. I would really appreciate if they look again at the startup time. Compared to the old devices, it got almost double as long, and I don't see a reason. I guess the hardware is equally fast, it's kind of the same software running. There is something going on that kind of doubled the startup time. I think this is something can be addressed. I think there are a couple of improvements in the user interface, the font size definitely for all the firmware upgrade that got worse. The visibility of the LED buttons and the color scheme, these are hardware things, so I don't expect them to change that easily. Please add also date time setting for files, because it's super inconvenient for documentation purposes if every file is dated the 1st of January 1980 at midnight. And I would also appreciate if a bit of work was done on the user manual. In many cases, it's not very complete or even simply incomplete. For example, the screenshot function is missing, just to name one, and any detail about its implementation of pseudo-random codes is missing. Unlike like manuals of all the other devices that I have that do that, they explain basically what are the basic rules for the code, if they're compliant with any standard, how many zeros or one can follow in sequence, if it's inverted or not, you know, all these specificalities about the code, etc. Please offer them so we know what we actually are getting. Now getting to the big question: should I buy or upgrade the new SDG100X Plus device? Now, as I said, the answer to that question is a bit complicated. It depends a little bit where I come from. I'm going to try to do my best on the basis of the observations that I made today. And in order to feed that discussion, I think we do have to look a little bit at price positioning. So here I plotted the street prices for the 3 different series that I've been looking at today, as they are right now in the Netherlands. And an important observation is that at least for bandwidth up to 40 or 60 megahertz, the prices are relatively close to each other. There is not a huge price penalty into choosing another model here. So is it worth buying one if this is your first or a new signal generator? I would say generally yes, like it is generally yes for I think all the models in these different series we've been looking at, because all of them are pretty good devices, they're solid, they work well, I've been using them with pleasure for a long time. It's a capable and decently priced device, like its siblings. With this model in particular, you get most of the 2000X performance at a somehow lower price point. I would say definitely buy this one if you need a web server or you need LXI, because it's the only one that offers that. About all these new functionalities that Siglent is advertising with, I think it's a bit of a mixed bag. I'm not sure that that's valuable or that are implemented that well. So really look carefully into that if you really have particular expectations there. And you might also consider just to buy the cheaper model, its predecessor, if you do value the higher frequency square waves and rise time, or if you simply want to save about 30% of the purchasing cost. Then the question, is it worth to upgrade to this new unit if you already have a 1000X unit? Well, perhaps it is. I mean, you do get much more waveform memory, you get 16-bit instead of 14-bit, and you get most of the specs of the 2000X series at a somehow lower price. It is worth to upgrade if, again, you need the web server or LXI for laboratory automation, then there's no question about it. And again, as already noted, for the new functionality, it's a bit of a mixed bag. And if you're interested in pseudo-random bits, you may just want to use the ARP of your existing generator for it, because it seems to be just as good at that, if not better. And if you upgrade, you lose one of the nice features of the cheapest model, that was the very nice square waves and rise times as well. And finally, is it worth as an update to the 2000X series? I think probably not. Only if you really need this web server or this LXI, it's the only one that has that. Or only if you really need to have one of these new other functions. But then again, I already noted they're a bit of a mixed bag in terms of implementation. And again, if you want to do some things like PRBS, you're probably better off just using an ARP generator, because the new PRBS functionality just doesn't seem to be doing what it's supposed to be doing. I'm happy if somebody comes to other conclusion and explains me why, but this is my conclusion so far. I would say finally that this is a kind of an interesting companion to the 2000X, to buy both of them because of the multi-device sync function. And then you can have both the devices running in sync with each other, acting more or less like a 4-channel generator. I'm planning a new video where I'm going to go in detail on this mode. This was already such a long video that I didn't get to doing that all in test, but you can expect that somewhere in the near future. And that was my in-depth review of the new 1000X Plus series. I hope this was a useful video to you, and do subscribe to my channel, and see you next time.